What we're going to look at today are dilations, and what a dilation is, or a non-rigid transformations. It makes a figure get bigger or smaller by applying a scale factor. So a dilation, again, makes the figure get bigger or smaller by applying a scale factor. Okay, so again, we are based off of the number 1. If 1 is less than your scale factor, or your scale factor is greater than 1, the figure gets bigger. And if your scale factor is less than 1, your figure will get smaller. Okay. And with dilations, if you think about your pupils, when you turn on the lights versus turn off the lights, right? When you turn the lights off, your pupils get bigger so they can bring in more light. But when you turn on the light, your pupils get smaller because they don't have to work as hard to bring in light so that you can see. Okay. And all you do here, it'll be dilation of K and then object, where D means dilate, K, like our constant from variation, is our scale factor, and then your object is what's getting moved. Okay, and then just like with any other transformation, rigid transformation we've done, do this point by point. Okay, so if J is 2, 4, by a scale factor of 2, all we're going to do is do 2 parentheses 2, 4, and we're going to distribute this 2 inside to both our X and Y coordinate. So it will become 4, 8. K is 1, 1. So it'll be 2, 1, 1. Again, distribute, and when we distribute, we multiply, and it will become 2, 2. L is 4, 0. So 2, 4, 0 would make it 8, 0. And then you would just plot it. Okay. So again, start off trying to do just your points. And if you can't do just your points, then actually plot your figures. Okay, so graph the dilated image of a quadrilateral MNOP using a scale factor of 1/3 and the origin as a center of dilation. Again, 1/3 is less than 1, so I know I have, or my new figure is going to get smaller. So if I use M, it's 3, 2, 3, 4, 5, 6, 7, 8, 9. So 1/3, 3, 9. 1/3 times 3 is 1. 9 times 1/3 is 3. So I would then go to my answer choice, look and see which one had M prime at the point 1, 3. If it doesn't, I'm going to get rid of it, move on to my next answer choice until I do find one. And then if I have 2, I would just move on to the next answer choice, or I would then go to my next point, N, which is 6, 0. 1/3 times 6 is 2. 1/3 times 0 is 0. And it will become 2, 0. So this is N prime. And then, finish the last 2 points if necessary. So number 5 is interesting because sometimes you'll have figures that have straight edges as the side of your figure. These are super easy, okay? Because what you do is you just count the distance up and down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So OP had a length of 15. And this is my pre-image because I don't see the little tick marks. O prime, P prime. My tick marks tells me this is my image because it comes second and it has the tick marks. And I find the length 1, 2, 3, 4, 5. So 15 to 5, what do I know about it? It gets smaller. Okay. So 15K is equal to 5, and then just solve for K. So I would divide by 15 both sides. And then K is equal to 5 over 15. Reduce it. K is equal to 1/3. So it's a dilation with scale factor of 1/3. Okay, versus having to use your distance formula, or I'll use a different one. So I'll use M. M starts out as 3, M prime is 1. So 3K equals 1, and then 3K is also equal to 1. And again, we get K is equal to 1/3 for both of these. If you have a table, right, and it gives you your coordinates, figure out what times my pre-image value equals. So -2 times what is -6. So -2K equals -6. Divide both sides by -2. K is equal to 3. So we would just come in here and multiply all of these by 3. And those are my points. And that's about it for dilation. So multiplying, dividing, solving one-step equations.